Hello, Eric Darling here with Eric Darling Data, and I am here to apologize and make right on a video that I recorded yesterday about CmemThread and the plan cache. I was devastatingly, horribly wrong, and I didn't realize it until later that I had a setting on on my server, on my laptop, on my database called QueryStore turned on. And the CmemThread weights were not the fault of the plan cache, they were the fault of QueryStore. And I'm going to show you exactly what happened. So right now, I've got some queries up on the screen. This query here will tell me if I have optimized for ad hoc workloads turned on, if I have parameterization set to forced or not, and the state of my QueryStore thing for the Stack Overflow 2013 database. I've also got some queries here to turn QueryStore on and off and to clear it out. So my capture mode is going to be read-write. My max storage size is going to be 100 megs. My capture mode is going to be auto, meaning I don't capture absolutely everything. I only capture stuff that SQL Server thinks is important. And I've got size-based cleanup mode turned on, meaning when QueryStore hits 100 megs, size-based cleanup should kick in and clear everything right out. I've also got some queries here to look at how many cached plans I have, and to look at if I'm hitting CmemThread weights, and to look at the current size of QueryStore for the Stack Overflow 2013 database. I've got some other utility queries down here. This is to clear out the plan cache and to clear out weight stats on my server so that I can refresh things in between runs to show you differences. I've got my ostress command here set to run 20 copies of my randomizer store procedure, which I'll talk to you about in a minute. And that does some stuff over there. And then I've also got queries to turn optimize for ad hoc workloads on and off, and just set parameterization to simple and forced. My randomizer query looks like this. It's a store. It grabs some weird values from the sys.messages table, sticks them in a cursor, and basically iterates over that cursor. And depending on what seed value this thing has, let me stick a semicolon there and make sure that I have everything correct. I would hate to not terminate a statement properly, but depending on what number comes up here, I'm going to select from a different table in the Stack Overflow database, depending on that. So if it's 1, badges, 2, comments, 3, posts, 4, users, 5, votes. And I'm going to pass the 2 little funny values that I get from sys.messages up here, which looks something like this, into the in clause down here. So that's what that randomizer store procedure does. It's pretty simple. Pretty simple stuff, right? Good stuff there. If we come back over here, what I'm going to do is I'm going to look at what I currently have going on. And in my datas, various datas, I have 169 plans in the cache. I have no CmemThread weights. And QueryStore, because it's off right now, has a size of 0 megs. Now what I'm going to do with QueryStore off, and this is to set up a baseline, is let me clear that out. And what I'm going to do is I'm going to kick off that ostress command, and I'm going to look at what happens. Now we're running that query across 20 threads just to simulate, like, sort of a heavy ad hoc workload. And as we hit F5 on these, the plans in the cache will start going up, and CmemThread weights will stay relatively low. Right now we have 10,000 plans in the cache and no CmemThread. So if I keep running this and looking at things, I don't know why that changed context on me. That was a little bit weird. But if I keep running these, now I have 51,000 plans in the cache. 21 things have waited on CmemThread, and that's not a lot. I'm going to go over here, I'm going to keep running these. About 73,000 plans in the cache. Still relatively low CmemThread. Only 70 things have waited on. I'm not worried about this kind of CmemThread wait. If I just keep doing this, CmemThread is not going to go up a whole lot. That's the baseline. That's to show you that it's not the plan cache's fault that our ad hoc workload is generating a bunch of CmemThread. It's not the plan cache. Whoever says it's not the plan cache out there, I agree with you 100%. It is not the plan cache's fault. Now, I want to show you what happens that's different when I turn QueryStore on. So I'm going to hit this. and I'm going to set QueryStore to on for this database, and so we are now capturing data. If we go back up here and rerun this query, we will see that QueryStore is set to read-write, and so the desired and the actual state are both in read-write mode. So cool, we have QueryStore turned on. We should be rocking and rolling at this point. Let's go rerun our workload again. F5 there, not F5. Hit enter there. Sometimes I get confused. But now when I start running this, CmemThread weights are going to start jumping up really, really quickly. So hit this, and we're at 12,000 plans. And as we go up, CmemThread weights are going to go up and up much faster than they do with without QueryStore turned on. So you can see that I'm hitting some weights here. I'm already up to 1,000 CmemThread weights, and you can see the size of QueryStore steadily increasing. We're up to 63 megs, we're up to 69 megs, and as we keep going up here, CmemThread is going to keep increasing. CmemThread is going to keep going up and up and up. So this was not happening with the plan cache. This is only happening with QueryStore turned on. So now I'm running all this stuff, and now we're up to 4,200 CmemThread weights, and now the QueryStore size is bigger than the max size that I set it to. If I keep hitting this, QueryStore is going to keep getting bigger and bigger and bigger, and our CmemThread weights are going to keep going up and up and up. Right now, the current size of QueryStore is 166, 173. This is just going to keep going up, and CmemThread weights are going to keep going up with it. QueryStore is now at about twice the max size that I set it to. Size-based cleanup should be kicking in and clearing stuff out. I just don't think it can keep up right now. So I'm sticking all these queries in, I'm hitting this, and you can just see everything piling up. QueryStore is now nearly 250 megs, and CmemThread weights keep on going up and up and up and up and up. Now, this can be a real problem for a lot of people. If you have an ad hoc workload like this, you might be very concerned that the QueryStore is gonna overfill, that it's gonna never cleanup is never gonna quite catch up, and now you're gonna have all these funky CmemThread weights going on your server. At this point now, QueryStore is nearly 3 times the size of the max size that I set it to, and cleanup doesn't really seem to be doing its thing. We're getting up really close to 300 megs there. So what I'm going to do is I'm going to kill off of this, and I'm going to talk about a couple options that I thought I would walk through to try and fix this. Now, the first one that I tried was optimize for ad hoc workloads. Now, if we look at to turn optimize for ad hoc workloads on, if you're in Azure SQLDB, you can do this with a database scope configuration. If you're on regular SQL Server, you can't. It would be nice if that made it there. I tried it last night, and I just kept getting errors. And then I looked at more closely at the documentation. It was like, oh yeah, only for Azure SQLDB. So right now we can only turn this on at the server level for SQL Server 2017. So I'm going to do that. I'm going to turn on Optimize for Ad Hoc Workloads, and I'm going to give one more check-in up here to see what things look like. And you'll see that now that our QueryStore size is nearly 400 megs. Size-based cleanup is not doing its thing, so we're going to do its job for it. And hopefully this will work. Hopefully. We might be sitting here for a while. Yeah. Oh, there we go. That only took 13 seconds. Good for us. Okay, so let's see how big QueryStore is currently. All right, 0 megs. Good, we cleared all that stuff out. And let's go check our stuff over here. So now we have optimized for ad hoc workloads turned on. That is at 1. Sweet. Now, with that at 1, let's go clear out all that stuff that we had before. And let's check back in. Let's make sure our queries are returning close to 0. All right, so 4 plans in cache. I can live with that. That's some system stuff going on in the background. CmemThreads at 0s across the board, and QueryStore is off, so we're at 0 there. Because we have a baseline with the ad hoc, with the workload running without any special settings, and CmemThread being low, I'm not going to repeat it with QueryStore off and ad hoc turned on. There's no point. That's not helping us here. That's not helping the effect that we're having. The effect that we're specifically having is that with QueryStore turned on, we hit a lot of CmemThread weights. So I'm going to turn QueryStore back on. So now if we go check in on this, we should see QueryStore set to read write, and we should see the value in use set to 1 for ad hoc workloads. Okay, with that in place, let's go back over here. Let's hit F5. Let's see, we have 10 plans in the cache now, good heavens. We still have no CmemThread, and of course, QueryStore size is 0, because why would it be anything else? We just turned it back on. Let's hit F5 there, or enter, or up arrow, enter, or whatever you want to call it, whatever O stress. And then I'm going to start running these. And when I run these, plans in the cache are going to start piling up. And so is CmemThread, and so is the size of QueryStore. And if I keep doing this, and we keep looking at stuff, and again, this just keeps bizarrely changing context on me, we'll see kind of the same pattern start to happen, where my mouse refuses to click and work in the right way. I don't know what it is. I need to stop spending $100 on mice that stop working after a few months. It's pretty ridiculous. But if I keep running these queries, we're going to see the number of plans in the cache pile up. We're going to see the CmemThread weights pile up. And we're going to see the size of QueryStore just keep going up and getting bigger and bigger. The two important things to take away from here is that Optimize for Ad Hoc Workloads is not fixing this specific problem where we're hitting CmemThread weights and the size of QueryStore is going up way above the max that we set it at. Size-based cleanup is also not doing its job in cleaning this thing up fast enough. So we're actually facing the exact same problem. Optimize for Ad Hoc Workloads isn't helping us here. I'm not going to let that run for as long because we already know kind of what's happening. So let's get rid of QueryStore. We already killed our workload. Going to get that off. Okay, cool. Now let's turn off Optimize for Ad Hoc Workloads. I want to make sure that I have a fresh start here. And let's turn on Forced Parameterization. So Forced Parameterization is turned on. And let's clear out all of this stuff. And let's see what we have here. Ooh, wrong button. It's a morning of wrong buttons. All right, so 4 plans in the cache. No CmemThread weights. QueryStore is, of course, at 0 megs because we have it turned off right now. So I'm going to go turn QueryStore on. Bada bing, bada boom. Let's go make sure that we have all the stuff we want here. Perfect. So read, write, parameterization is set to forced. All right. Let's check in on these numbers, make sure we don't have anything too weird. We don't. 9 plans in the cache, no CmemThread. QueryStore is at 0 because we just turned it on. And we're going to go hit whatever you want to call that button, we're going to hit it. I'm going to run this thing. Run it. Come over here, highlight you, and let's start running this thing. All right. So what we're going to notice with forced parameterization turned on, at least if this demo works as it has worked all morning, which it very well may not. Who knows? As soon as you're recording, every bad thing happens. Everything goes wrong when you start recording. Anyway, so what we see here is the number of plans in the cache is skyrocketing. We're up to 100 and something thousand, 157,000, but very low CmemThread. The other thing I want you to notice is that the size of QueryStore is 0 megs. It's not that we're not collecting anything. It's just that when SQL Server is doing a pretty good job of only putting 1 copy of the parameterized plan in there. So as we go through and we look at this, we can see that QueryStore's size is not ballooning. CmemThread weights are staying relatively low compared to other other times when we ran this, but the number of plans in the cache is sort of astoundingly high. Now, I'm going to keep running this, and we're basically what we're going to see here is that forced parameterization does help us avoid the majority of the CmemThread weights and the ballooning size of QueryStore. For some reason, it's not helping us with the plan cache. The plan cache, we're still not getting very good plan reuse. So that's an issue, but that's an issue for another day. This video is pretty specifically aimed at CmemThread weights as they relate to the QueryStore and how big the QueryStore gets and how it doesn't clean up and all the other kind of crazy stuff. I had a much worse time with this last night when I was originally running through the demo trying to get it worked out, where at one point QueryStore was 700 megs, and the only way I could get it to turn off and clear out was by restarting my entire laptop. And that was not pleasant because in my head I'm thinking, my God, if you're doing this in production, you don't want to have to restart production just to get QueryStore to clean out. Anyway, my name's Eric. Darling, that one, with Eric Darling Data. And thank you for watching. I hope you got some useful information out of this, and I will see you, I don't know, maybe in a week or so, because it's the weekend and I feel like doing other things. Goodbye.